Hello, thank you for watching this video. So in this video I'll be doing question 4 of November 2022, question paper mathematics paper 1, and these are functions. So we'll start with this one here, which is the hyperbola. So I'm going to read the statement and then answer the questions that follow. So question 4, 4.1. Sketched below is a graph h of x is equal to 1 over x plus p plus q. The asymptotes of h intersect at 1 and 2. Let me read the statement again. Sketched below is a graph h of x is equal to 1 over the sum of x and p plus q. The asymptotes of h intersect at 1 and 2. So basically what they're telling you is that you have the sketched, you have this sketch here, which is this function here, and which have this equation here. That's basically what they are telling you. They are also telling you that the asymptotes meet here at 1 and 2. So your horizontal asymptote is y is equal to 2, and the vertical asymptote is your x is equal to 1. That's what they are telling you. So 4.1.1. 4.1.1. What does it say? Write down the values of P and Q. They want you to write down the values of P and Q. Okay, so to write down the values of P and Q, right? So you know that on your general equation, you have your general equation for the hyperbola is y is equal to a over x minus p plus q. This is the general equation of your hyperbola. So you just substitute your p and q on that as well. So your h of x is equal to a, my a is 1 all over x, because a is this part which is there, x minus p, my p is your vertical asymptote which is 1 plus q, and q is equal to the horizontal asymptote which is plus 2 here. So this is the full equation of this function here, of this hyperbola. So your p is here and your q is there. So your p is equal to this part here. It's minus 1, and your q is equal to 2. You're done with this one. Go to the next question. Calculate the x-intercept of h. So they want you to find the x-intercepts of h. They want you to find the x-intercepts of this, right? Okay, so let me do it here on the side. 4.1.2. 4.1.2. So they want to find what are the values of x, the coordinates where your function intercepts the x's. Oh, sorry, the x-intercept. They want you to find the x coordinate here. The x coordinate. They want you to find the x coordinates of this function here at the x-intercept here at this point here. Because they want you to find the intercepts. What are the coordinates of that point? Or what is the x coordinate of that point? So you know this line here is the line x-axis, right? So it's the same as y is equal to, it is the same as y is equal to 0, because here along this line y is equal to 0. So this is the x-axis, right? And this y line y is equal to 0. As this horizontal line here is x equal to 2. Sorry, y is equal to 2. This one is y is equal to 0. So you know the y coordinate already there, that y is 0 there. So what you're looking for is the x coordinate. So you know that your where at your x-intercept, your y is equal to 0 there, because when your function intercepts this line, the y coordinate is 0 there. If you're just intercepting this line, the x coordinate is 0 there, because this line here is the line x is equal to 0. Same argument. So we know our y is corresponding x value. So to do this, put substitute your y is equal to 0, that's 0, is equal to 1 over x minus 1 plus 2. Then you solve for x, then multiply throughout by this. Okay, actually let's transpose this to the other side. Minus 2 is equal to 1 over x minus 1. Then you cross multiply, this time that. So you have negative 2 times x minus 1 is equal to positive 1. It's going to be 1 times that. Then this time this, minus 2x, this time that, plus 2 is equal to 1. Then you transpose the 2 to the side. So you're left with minus 2x is equal to 1 minus 2, which is equal to minus 1, right? Then you divide by minus 2, divide by minus 2, which is the x is equal to minus positive 1 over 2. So your x coordinate here at this point is 1 over 2. 1 over 2. So the coordinates of that point is 1 over 2 and 0. This is what this tells you. This is how you do this. You have answered 4.1.2. So we have 4.1.3 now. 4.1.3. So write down the x coordinate of the x-intercept of g if g is equal to, g of x is equal to that. So they want you to write down the x coordinate of x if g, they want you to write the x coordinate of the intercept of g, right? If your g is equal to h at x plus 3. So they want you to find the x coordinate of this, right? If they want you to find the x coordinate of this guy here. If this graph is equal to h of x plus 3, h of x plus 3, what does this mean? It means that your graph has been shifted 3 units to the left. This is what this tells you, which means now you have a similar graph to this one, except that it's shifted 3 units to the left, which means if this one here is with 1 over 2, it's going to be at minus 2.5 or minus 5 over 2, because we're just moving 3 units to the left. So the x coordinate, what is it? The x coordinate of g will be x is equal to minus 5 over 2, which is equal to minus 2.5. So the coordinate is minus 2.5 and 0. Those will be your new intercepts, which will be on that side. 3 units to that side, because this is what you're doing, just shifting your function 3 units to the left. That's it. 4.1.4. The equation of axis of symmetry. The equation of axis of symmetry of h is y is equal to x plus t. Determine the value of t. So we are told that the equation of an axis of symmetry of h is that. So an axis of symmetry, it is a symmetry line which goes through the intersection of your asymptotes, which split your graph into 2 identical parts. So it should be a straight line. Don't mind that curve you're thinking. So this is our symmetry line. It goes through the intersection of the asymptotes. So you are told that this line is called x plus t, right? So they want you to find the value of t. So you have the gradient of this line, it's 1. So you have at least one point which is where they intersect, which is the intersection of the asymptotes. Then you can find the value of t, because you have your x, you have your y, because this symmetry line goes through the intersection of the asymptotes, where asymptotes intersect, which is that. So you can find the value of t. That's what we're going to do clinically. So 4.1.4, right? We have y is equal to x plus t. So, and you know one point on this line, which is 1 and 2. So you want the value of t, you have your x, you have your y. So which means substitute your y there, which is 2 is equal to 1 plus t. So you transpose this to the side, so t is equal to 1. Therefore, y is equal to x plus 1. So that's the equation of that x of symmetry through the asymptotes of that function. This is how you do this one. Okay, so determine for which values of x is negative 2 less than 1 over x minus 1. So find the values of x. So this is 4.1.5, right? Find the values of x for which minus 2 is greater or equal to 1 over x minus 1. So they are asking you to find for which values of x is this thing is negative to less than this. Or it's more essentially you're solving for x here, right? So, and if you look at this, or remember when we looked at for our asymptote, we transpose the two which is on this side, because our equation was like this: h of x is equal to 1 over x minus 1 plus 2. So if you look at this, it's more like these two have been transposed to the side, if you're looking at this thing. So we can transpose the two back and see what it looks like. So if you transpose the two back, we say 0 less or equal to 1 over x minus 1 plus 2. This is your equation this is the equation of this graph, which is what you were given. And you are given the plot as well. So what they're asking you, they're asking for which values of x is this thing positive. What are the values of x is this thing positive? That's what they're asking you. Where is it positive? By looking at this, it's positive here. This direction, and it's positive all of it this side, going to that direction. What are the x values? So the x values for which it is not positive, non-negative, which is greater or equal to 0. Non-negative, including, which is, also include the starting points. This is not positive. This is non-negative. So they are asking for which values of x is this thing non-negative, which is greater or equal to 0. So those values of x are these values here, going to this direction, and the values before this side on the right side or of 1 going to that direction, which is greater than 1. So the values are x is greater than 1, and these values here, which is your x is less or equal to 1 over 2. So this thing will be non-negative, which is greater or equal to 0, that direction, and here this direction, which means your x values is you'll say your x should be less than or equal to 1 over 2, or your x is greater than 1. So you can say your x is an element of negative infinity to 1 over 2 union 1, this should be a square bracket, this one, because this one is included, union 1 to infinity. So this is it. If you are unfamiliar with this, watch class 1 or class 2. Class 1 and class 2 of my, actually class 2 of my maths basics. You will learn how to do this. And this one as well. What else? 4.1.5. So we're done with 4.1. Then we go to 4.2. I'm going to stick the drawing for 4.2 and then answer 4.2 questions. So the graphs of f of x is equal to x squared minus 4x minus 5 and g of x equal to a times 2 raised x plus q are sketched below. And you are told the following: E and H are x-intercepts of f. C is the y-intercept of f and lies on the asymptotes g of g. The two graphs intersect at g, the turning point of f. I'll read the statement again. The graphs of f and g are sketched below. E and H are intercepts of f. C is the y-intercept of f and lies on the asymptote of g. Okay? The two graphs intersect at D, the turning point of f. So you are given this graph here. That's what they're telling you. These two graphs, which is f, which is this equation, and g, which has that equation there. Right? Which has that equation there. And you are told that E and H are intercepts of f. E and H are intercepts of f. Straightforward. C is the y-intercept of f. C is the y-intercept of f, and also lies on this asymptote, which means your asymptote goes through C, which is the y-intercept of f. The two graphs intersect at G. They intersect here in G, at the turning, which is the turning point of what? Of f. Great, straightforward. So 4.2.1. Let's write it. Write down the y-coordinate of C. They want you to write down the coordinate of C. It's the y-intercept of what? Of it's the y-intercept of f, right? So I can read it straight here, but I don't want to do that. So I will say, okay, this is the y-axis. This is the y-axis, right? It's the same as saying what is the line x is equal to 0, and this is the x-axis. The same as saying this is the line y is equal to 0 here. So at this point here, we know the x value is 0 along this line. So we know the x value is 0. So we'll substitute 0 on our graph to find the corresponding y value, which will be this. Because your graph, if you want the coordinates of C, right? So if you want to find the value of C, which is the y coordinate of C, you must substitute the its x value here that you know. You know that its x value is what? Is 0. So you substitute 0 here, here, and there, and then find the value of your y-intercept. Or you can just read this straight from there. So I'll say, okay, it's C. C is their y-intercept. There. So we know its x value is equal to 0 there. So the y value, you'll find it by saying, okay, I'm going to substitute my x value here. So f at 0 is equal to 0 squared minus 4 times 0 minus 5. And this is equal to minus 5. So the coordinates of C. So C is equal to minus 5, which is the y-intercept there. You could have just read it straight there, but this is the principle. So that you know when you want the y value at a point, you substitute the x value on the original equation, especially when you have that original equation like we do here. Determine the coordinates of D. What is D? So D is, what is your D? So D is the turning point. You're told that two graphs intersected D, the turning point of F. So they want you to find what? The coordinates of D. So to find the coordinates of D, the turning point, you say, okay, so 4.1.2, 4.1.2. I know you can find, you know that you can find the x coordinate because it is the x of symmetry here, right? So you can find the midpoint of these two, but you don't have these because you can. One way you can find this point here, you can find the midpoint of these intercepts, but you don't have the x values of the intercepts. Or you can say, okay, the x coordinate of the turning point is equal to minus b over 2a, right? Which is equal to minus b. What is your b? Your b is equal to minus 4. Minus 4 over 2a. What is your a? Your a is 1. There. So if you punch this in your calculator, you'll quickly discover that your x coordinate of the turning point is 2. So your y coordinate, you'll find it. So now you have the x coordinate of the turning point, that is 2, right? So you will find your y coordinate the same way you found this one, by substituting the x coordinate you have on the original equation. So this is your x coordinate of the turning point. So you have the x coordinate. To find this corresponding y value, you substitute there, which is f at 2 is equal to 2 all squared minus 4 times 2 minus 5, right? And this is 4 minus 8 minus 5, right? So so you have minus 4 minus 5, which is equal to minus 9. So minus 9. So your coordinates of D, x coordinate is 2 and your y coordinate is minus 9. Those are coordinates for D. Done with this. Then you go to the next one. Determine the values of A and Q. They want you to find the values of A and Q, right? You know the value of Q because it is the same as this is Q, the horizontal center is going through C. So you know that is equal to 5. So 4.1.3. You know the value of Q because you are told that your horizontal center is going through C and you found the value of C here to be minus 5. So your Q is equal to minus 5, right? Also, so now your equation G looks like this. G at x is equal to A times 2 raised x plus minus 5. So you're only missing what? You're only missing A, right? So since you're missing A, if you have one point, your x and y on this graph here, you can substitute your x value and your y value, your point that you have, and find the unknown. So here, you are told that G intersects with F at D. So you know the coordinates of D. And the coordinates for D is 2 and minus 9. That's what you have. We have that is 2 and minus 9. So so you have that your coordinates that are also on this graph, because 2 and minus 9 are also on this graph as well, which is G. So you have 2 and your minus 9. So you can substitute these here and you'll be left with your unknown. So minus 9 is equal to A times 2 raised x, which x is 2, minus 5. Right? So what do you have? You have that negative 9 is equal to A times 4 minus 5. Right? So you transpose this to the side. You have minus 9 plus 5 is equal to 4A. So you have what do you have? This and this is minus 4 is equal to 4A. Divide by 4, divide by 4. Your A is equal to minus 1. Right? So your A is equal to minus 1. So you found your values for both your Q and A. This Q is minus 5 and your A is minus 1. Which makes sense because you can see the shape of your graph just going down. So go to the next one. Write down the range of what? Of G. They want you to find the range of G. What is the range of a function? So your range of a function, it is the set of y values that are going to be used by your graph. What are the y values to which your x values are assigned to? So all your x, you can all agree that your y value, your this graph will only use the y value, will only be defined for the y values that are below this asymptote here. That's it, that is your range. Because you're looking at the graph, where is what y values are occupied by our graph or are being used by our graph. So it's the y values that are below our asymptote there. So our range, I'm going to write the range now. I'm going to clean the board. So 4.2.4. So our range, I said that it's the set of y values that are going to be used by this graph, which are those that are below here. That's our range for 3. So our range is y is less than the asymptote to that one, which is c, which is equal to -5. Should be strictly less than 5, because this asymptote will never, this function will never equal to -5. It will always be below that. It will just be approaching or getting closer and closer to -5. That's the best this thing can do up until forever. Or you can write it as x, as y is an element of -infinity. This open interval here. Yeah. So 4.2.5. Determine the values of k for which f of x minus k will always be positive. So find the values of k for which f of x minus k is always positive. That's what they're asking you. So they want you to find the value of k such that this thing, our function f, which is this function here, is always positive, right? So how many marks? It's 2 marks. So this thing will always, I think it will always be positive if it is above. If this point here is sitting above 0 here, which means if this graph maintains the same everything, but its turning point is above here, above this line here. That's what you need. So which means you need your graph to be above what? To be above your 0 here, which means you will need to move your graph by at least 9 units, because if you by greater than 9 units, let me just say that, because if you translate it upwards or shift it upwards 9 units, then it will be sitting at 0 exactly. So you need it. You need your graph, this graph here, to be above 0. That's what you need, which means you need your f minus k should always be above 0. That's what you need. So at this very moment, you have that your k, your lowest point is what? Is -9. So your -9 minus k should always be greater than 0. That's what you need, which means your sorry, I made a mistake here. So this is k less than -9. So k should always be less than -9. So that means your k is an element of negative infinity to -9. This is what that means. So just in case, I suspect that I made a mistake when I was explaining earlier. So you want your f of x minus this to be 0 at all times. This is the smallest f of x that you can possibly find here. Smallest y value that you can possibly find. So you want to put it up there. So this is all the values of k less than -9 will have your graph up there. So you want your k to be less than -9. So it should be in this interval, option interval. And I think you're done with this question.